be sharp by these. Number 1, you have to translate the following. 6 less than, sorry, you guys have 21, not 22, right? Or do you have, I don't know, 21. So that's, here we go. What is the slope of the line between, or what is the slope between -3, 4, and 6, 1? You need to subtract. So 1 minus 4 over 6 minus -3. And you would get -1/3 as your slope. Questions on that one? Number 2, when it asks about the slope of the line, you have to remember a couple things. You could graph this, but if you remember your horizontal lines have 0 slope when y equals whatever. Because it's a y equals, this would be a horizontal line, so your slope is going to be 0. Question on the second one. Excuse me. For the third, is asking about the range of this graph. The range is lowest to highest. The lowest point on this graph is at -2. So you can write this one of two ways. Using your set builder notation or your inequalities. Y is greater than or equal to -2 because it keeps going up. Or using your interval notation, it would start at -2 with a square bracket and then go to positive infinity. Question on number 3. Number 4, you had to find the equation of this line. So that was going back like the second unit, where you had to find your slope and y-intercept. Your y-intercept was 1, and then you had to find another point on the line that would cross the grid lines exactly. So if you went up 4 to the right 3, you would get this point right here. Your equation would be y equals 4 over 3x plus 1. Questions on that one? And then for the last one, we needed to graph. Start at your y-intercepts at 3. Go up 2 to the right one as many times as possible, and down 2 to the left one as many times as possible. And then draw a line with arrows through it. Questions on that one? Everyone should have notes that look like this. Pull those out in front of you. This first page has a lot of vocab, so I'm going to scroll to the other page so you can get those filled in answers. We won't use all of this vocab, but you will see some of it. Some of it is like a preview for what you'll see in Algebra 2. First, all quadratic equations are written in the form y equals ax squared plus bx plus c. So we're thinking back to our factoring unit when we had trinomials. They were all in this form. They were all quadratics. Really, the difference of squares and the trinomials, those were all quadratics. The grouping or the DCF could have been, it could have not been, it depended. When we graph quadratics, it will create a U-shaped curve called a parabola. So anytime you hear or see that word, parabola, U-shape, quadratic, they all go together. Really quickly, draw a rough sketch of these two. It does not have to be perfect. We'll talk more about what a vertex is here in a bit, and the line that's going through it. If your a value, the number in front of x squared, is positive, your parabola is going to face up. If the a value, or the number in front of x squared, is negative, your parabola is going to face down.
What was the one that was in
Parabola, P-A-R-A-B-O-L-A. Anyone still need this part? Our axis of symmetry is the vertical line that divides the parabola into two equal parts. So as we start to draw this, we'll be using this, and then as we actually start to draw it, we won't really, we'll just be looking for it, and then we'll be able to see where it would split the parabola in half, kind of be a mirror. There is a way to find this. It's using this formula, x equals negative b over 2a. The negative is there no matter what. And once we figure out that formula, put everything in, we get x equals some number. And then the last thing is the vertex. This is the turning point of the parabola. The vertex is usually on the axis of symmetry. I'm going to scroll up really fast. So here when we have these vertices, when it's at the lowest point because your A is positive, this is a minimum. And when it's at the highest, this is a maximum. Our vertex is going to be written as an ordered pair, so in the form xy. Anyone still need this part? The topic, graphing quadratics. Alright, we're going to do this first example, and that's probably all the time. Go grab your calculator if you don't have it. to find our axis of symmetry, so we're going to use that formula x equals negative b over 2a. Our b and our a come directly from our equation that we're given. This would be x equals is always negative no matter what, unless our b value is also negative, and that would change. But here we would put an 8 over the 2, and then our a value here is what? The number in front of x squared. 1. So we would then simplify this so that x equals negative 4, and that would be our axis of symmetry, x equals negative 4. To find our vertex, we have to get our y value. So we're going to take the number we just found and put it into all of our x's here. So y equals negative 4 squared plus 8 times negative 4 plus 15. You could do that by hand, but we're going to do it in a calculator. Make sure you're using parentheses. And you should get negative 1 as your answer to y. We have y equals negative 1. Then we would take that x and that y, put them together in our vertex. Negative 4, negative 1. And then we're going to draw a rough sketch. So draw in your x and y axis. Again, this is a rough sketch. It does not have to be perfect. Then we're going to draw in our line, our axis of symmetry. So it's going to be a vertical line when x is negative 4. I'm going to make this a dashed line. When your a value is positive, this is going to face up. We also need to put in our vertex, so negative 4, negative 1. This will lie on the axis of symmetry. And then a is positive, so this is going to face up. So I'm going to draw something that looks like a U-shape facing up. This is a very rough sketch.
Why is it?
Because the value in front of x squared is positive.
Oh, right.
Okay. Have a good one. On the back, number 2. Do the same process and find our axis of symmetry. So here we have x equals negative 10 over 2 times negative 1. And then we could simplify that and figure out what that is. So our axis of symmetry would be what? y equals negative 5 squared plus 10 times 5 minus 23. And then we can put all of that in our calculator. I'm still going to put it in, but yes. I'm not, because the smart board doesn't like me. We're going to unplug and plug. Let's try it. So our vertex would be what? 5, 2. And we can draw our sketch. We would have a vertical line at x equals 5. And then our vertex at 5, 2. Your A value is now negative, so this would face down. Questions on that one? Let's jump down to number 5 and do the same process. So here we would have a negative from our original formula, but our 4 is also negative, so that's going to change our sign. And then we also have a negative 1. So when we simplify that, what would our axis of symmetry be? And our final answer? Negative 2, or just so then we can use that to find our vertex. This would be y equals negative, and then negative 2 squared, minus a negative, minus 4 times negative 2, minus 2. There's a lot of negatives and 2's in there. Be careful when you put that in. What would your y value be? So our vertex would be negative 2. And then we can draw a rough sketch of that. So x equals negative 2 would be a vertical line at that. That was not a very vertical line. And then our vertex would be at -2, +2. Your A value here is negative, so would this face up or down? Down. We're going to do a couple more of these, then I'm going to let you try some on your own. Do you have any questions on 5 before we do the next one? Let's do number 8 and then we'll do 10. For number 8, we're missing our C value, but that's okay. It'll be a little less work when we put in our vertex. So -4 over 2 times -1. What would the axis of symmetry be? X equals 2. And then we can put in that x value to find our vertex. So y equals -2 squared plus 4 times 2. And what would that y value be? That would give us the vertex Q4. And we can draw in our rough sketch. So our axis of symmetry is at 2. And our vertex will be at 2, 4. Would this face up or down? Because what is 2? I'm sorry, that. This would be 8. And this would be 4, but it's negative. -4 plus 8. Would this face up or face down? Look at your A value. This would face down. And then last one we'll do together, number 10. When we do our axis of symmetry for this one, we don't have a B value. So it's just going to be 0. And then if I put in everything else, we have 2 times our -2. But 0 divided by anything is what? 0. So our axis of symmetry is just going to be 0. If I put 0 in for my x, what would my y value be? 8. So our vertex would be 0, 8. And then we could draw this sketch. Because the axis of symmetry is on the y-axis, we need to outline that a little bit. And then your vertex would be 1, 2, 3, 4, 5, 6, 7, 8, somewhere up here. supposed to be on that line. Pretend it is. Would this face up or down? Down. I want you to go back and do the following, the ones you didn't do. So 3, 4, 6, 7, and 9.
Let me ask you a question real quick. For if you had $100, you're going to get the answer to this question. I want to know if you feel that confident. Ready?
I'm going to go through the answers to these, or not. I'm going to read off your axis of symmetry, your vertex, and then talk about the graph. So number 3, your axis of symmetry was x equals 2. Vertex was 2, -7. And this should have been facing up. Do you have any questions on that one? Number 4, axis of symmetry, x equals -1, vertex -1, 5, and this was facing up. Questions on that one? Number 5, axis of symmetry, x equals -2. I'm sorry, we did that one. 6, x equals 3, vertex 3, -9. This was facing up.
What if like
Say something about that is off. Did you get the right axis of symmetry?
I didn't do
So your negative from your formula, and then this was also negative. Those became a positive. And then 2 times this 2 would give us 4. So we would be dividing by 3. Or dividing by 4 to get 3. For 7, axis of symmetry, x equals -4, vertex -4, 6, and this was facing down. Questions on that one? And then number 9, axis of symmetry, x equals 0, vertex 0, -3, and this was facing up. Questions on that one? So this was a good practice for us actually graphing the quadratics, because we're still going to be using the axis of symmetry and the vertex. Flip over to the next page.
Maybe one thought. Just one thought. Just give one thought real quick. Related to the smiling and the frowning. What do negative people do? Do they frown or smile? I don't know negative. Just think of negative people. You see the negative people frown, okay? The other thing, if you see an opposite of B, negative B, what helps me sometimes, if you get a -2 in here, I sometimes think of an opposite. In other words, -2, so you got the opposite of B. So that to me says the opposite of whatever's in here. So I don't have to think negative with a negative. I just say opposite of -2 is a positive 2, right? So negative people frown, the opposite.
All right. So on this, just like before, we are going to find our axis of symmetry first. So that would be negative, what is our B value?
3.
0. We don't have 1. Our A value here would be 1, but that doesn't matter because this is going to become what? 0. So x equals 0 is our axis of symmetry. If we put that in to find our y value, what would our y value be? Also 0. So our vertex would be 0, 0. So that part is not new. What is new, we're going to take that vertex and we're going to put it in the middle of this table. 0, 0, directly in the middle. And then we're going to fill out our x's, so go forwards and backwards. Backwards would be -1, -2. Forwards would be 1, 2. And then we're going to use our calculator to help us fill out the rest. We could do the rest by hand, but we're not going to. So in your calculator, you're going to go into y equals. And you're going to put in this equation, your variable x, and then the x squared button. If you just hit the x squared button, you won't have your variable, so make sure you put in your variable first. After you have in your variable and x squared, you're going to go into your table, which is in second graph. So if you put second and then graph, you're going to get your table values. Our table starts at -2 when x is -2, so I'm going to scroll up. And then I'm going to start filling in my table. So when x is -2, y is 4. When x is -1, y is 1. Without looking back at my calculator, because the vertex lies on the axis of symmetry, the rest of the numbers should mirror what these already were. So this should be 1, and this should be 4. And I can go back and confirm. X is 1, y is 1. And x is 2, y is 1. So really, once you find those first two numbers, you have the rest of the numbers. Then we can plot all of these points. -2, +4, -1, 1, 0, 0, 1, 1, 2, 4. And we are going to connect the dots and make the U shape through these points. And draw arrows at the end. Before we talk about the domain and range of this, do we have any questions on how we did that? So this is going to be, once you find the vertex, put it in your table, fill out your table in your calculator, and graph those points. Right? Domain and range is not something you absolutely need in this class. This will be like a preview for when you really learn it in Algebra 2, those of you moving on to that. But we are going to talk about it very little. So your domain is all of your x values. If I'm looking at all of my x values, furthest left to furthest right, this keeps going up and to the left slightly, and it will eventually reach -infinity, way somewhere out there. It does the same thing on the right. It keeps going up and slightly to the right, off the graph. You kind of have to visualize it.
Forever.
So if it keeps going left and right, the domain is going to be all real numbers. The domain for quadratic equations or functions will never change. It will always be all real numbers, or from -infinity to +infinity. Always. The range, however, is what changes. So for your range, you're looking at lowest to highest. The lowest point would be when y is 0. Your value for your range, you're always going to find in your vertex. So whatever your y value is, it'll be somewhere in your range. So we're going to start at 0. And then this keeps going up off the graph forever and ever. So it's going to go towards positive infinity. Questions on that, Marta?
What would it look like if it was actually like somewhere
Facing down.
on the left, like the top left?
It doesn't matter where it is. These are not nice. The domain would stay the same. The range would be whatever at whatever point. It would start at whatever point and then still go up. Now, if it was facing down, it would change. Which we'll do a couple of those here in a bit. Number 2, same process. Find your axis of symmetry. So x equals -2 over 2 times 1. What would your x be? -1. And then we could put that in to find our y value. Put in your x's, or -1 into your x's. Figure out what your y value is. It's 4. So our vertex would be -1, 4. Oh, I meant to say this for the last one. So before we continue, we did not graph in our axis of symmetry, but if I were to look at when x is 0, there would be a vertical line along your y-axis. And I can see how that vertical line is directly splitting these in the middle. So we won't be drawing that axis of symmetry moving forward, but be able to recognize it, look for it, that it's cutting your parabola down the middle. So put -1, 4 in the middle of your table. Fill in your x's going forward and backwards. So backwards would be -2, -3. Forwards would be 0, 1. And then we're going to put this equation into our calculator. Go back to y equals, clear this out, or you can just add to it at the end. Plus 2x plus 5. I think that's what it was. Yes. And then go into your table, second graph. Our table starts at -3. So we need to make ours also start at -3. And then find your y value. So when x is -3, y is 8. When x is -2, y is 5. And then these should repeat, 5, 8. And then we can graph these 5 points. -3, 8. -2, 5. -4. 0, 5. 1. And then this would make my U shape facing up. The range would not change, it would still be negative infinity to infinity. Range would start at my y value of 4 and go to positive infinity. Questions on this? We'll do a couple more examples if we have time. I think we'll have time to do both. If not, we'll do one and stop, but I think we'll have time to do both. So for number 3, we're going to start doing the same process. We would have x equals negative 8. That would just become a positive over 2 times negative 1. So x equals negative 4. And then we can put that in and find our vertex. So we have negative 4 squared minus 8 times negative 4 minus 17. Is what? Negative 1 is, should be positive. No, you're right, it's negative 1. So our vertex is negative 4, negative 1. We filled in our x's going backwards. We have negative 5, negative 6, and then forwards, negative 3, negative 2. Put that in your calculator. I already forgot what this was. Negative x squared minus 8x minus 7. And go to your table. This one we need it to start at negative 6, so we need to scroll up until we get there. And then fill in your table. X is negative 6, y is negative 5. When x is negative 5, y is negative 2. And then it repeats. Back those points. Negative 6, negative 5, somewhere down here. Negative 5, negative 2. Negative 4, 1. This would not face down because our a value is negative. So still connect your dots, make that U shape, make your arrows, but make it facing down. Your domain would stay the same, negative infinity to infinity. Because even though it's going down, it's still going to go down and slightly to the left and slightly to the right. Your range, however, You're looking lowest to highest. The lowest, we don't know because it keeps going down. So that one would now start at negative infinity. And it's going to stop at -1, your y value from your vertex. Say that one more time. What was the last part with the... I just didn't hear what you said. What was the last part with the what?
Why is it flipping down?
Oh, because it's facing down. The lowest, we don't know because it keeps going down. So it has to start at negative infinity somewhere, and then its highest point is at -1. It does not go past -1. Oh, because it's included. So that goes back to our interval notation when we were doing inequalities. Okay. So even though it's going down, yes, you're looking at your x's. So your x's keep going slightly out, like this, and like this. So your x's keep going out, even though your y's keep going down. All right, really quickly, last one. Let's do number 6. Yes.
Why isn't the negative the same for a positive? Because with the positive, that's just like
The x's are going out, the y's are going out. You're talking about with the domain, right? The range. Well, the range is just your y values. Axis of symmetry, we're going to run through this a little fast. We don't have a b value. So we can kind of already assume this is going to be x equals 0, but I'll still write out this. Because we don't have a b value. If we put 0 into this, what would our y value be? -4. So our vertex would be 0, -4. So that would be our point in the middle. And then filling out our x's, -1, -2, 1, 2. And then I can put this in my calculator to fill out the rest of everything else. When x is -2, y is -8. And when x is -1, y is -5. And then it repeats. So that would be the points -2, -8, -1, -5, 0, -4, 1, -5, 2, -8, facing down. Your domain would be the same, and your range would be from -infinity to -4. Next class, you'll have time to practice more of these, and then we'll also be starting our next lesson with them.